This is the second day of a two-part webinar covering the topic, the Sharp 250 and the COM-EXT software. So let's begin. The second day actually will be covering transformer loss and Ctbt compensation, power quality and alarms, historical log configurations, log viewer and waveform, and hopefully we'll have enough time to get in the email server and notification. So the first part is the transformer loss compensation and Ctbt. So we'll jump right in. There are basically three types of losses or /error that the meter captures and can report. There's a radio line losses, or we call them transmission line losses. There are the transformer losses, which are based typically on the power transformers that we want to account for those losses when we meter. The meter are typically on the low side of the metering. And then the other compensation factor is the Ctbt compensation. So the plan is to cover all three compensation that the meter does perform. Won't go into too much depth, but basically give you a general idea. So the line losses. As we know, line losses are associated with transmission and distribution lines. And the purpose of the transmission and distribution lines, as we all should know, it's to transmit real power or active power. And this will also include reactive power, I should say, also because there are times where we need to transmit reactive power for voltage adjustments. And hopefully that is not a very large factor in the transmission. And due to the electrical properties, resistance, inductive and capacitive reactances of the lines, there will be losses. And these losses are very significant, and we always want to account for these. And many utilities choose not to adjust for the losses in the meters, and instead they factor in the losses in their billing. They usually account for a percentage or something that they've done historically, and that works for them. The loss factors are generally based on the physical characteristics of the transmission lines. So we talk about line losses. Here's actually just a little configuration of what when we talk about line losses. We have a transmission line, we have upstream, we have a master meter at the load side, and then downstream we have the energy meters. And those meters are where the losses would be calculated. The next set of losses we have are transformer losses. And these are typically associated with the power transformers, as I mentioned before. The power transformers used to step down the voltages from the transmission levels, and typically your customers are going to be industrial and municipality customers. The losses from the power can be very significant in these customers, and we would want to compensate for these. There are basically four options that you have to do this function. The meter installed on the primary side of the power transformer. That is a very expensive solution. If it's available, it's ideal because you won't have to do the actual loss compensation. Then you have the meter installed on the secondary of the power transformer, which is where we typically apply the transformer loss compensation. Then we have the third option, the meter installed on the secondary of the power transformer, where we manually estimate the losses. Typically in a spreadsheet format, you would have a fixed percentage and or energy total to generate interval data if you need it. And then fourth option is the meters on the secondary side of the power transformer, and you have to calculate those based on voltage and current in the spreadsheet. So those are the basic four options. So what we see here is a a power transformer, and on the secondary as the ideal, I should say not ideal, but the situation where we call low side metering, where we're metering on the secondary of the power transformer, and we want to apply compensation. Okay, the next, the last compensation that we look at is the Ctbt compensation, and this is the error correction factors. And let me just back up a little bit. It's the accuracy of any metering system is dependent on the instrument transformer. And the Ctbt compensation is used to correct for inherent errors caused by the current transformer and potential transformers. These are related to ratio and phase angle. And generally, you test the CTs and PTs and you produce a report that gives you all the correction errors, and you would apply that report to the metering to make the adjustment or compensation. So what I'll do is I'll bring up the screen here momentarily. This is what we have in the communicator. So I'll just jump right in and let's take a look at what that looks like in the programming. So I'm already connected to a meter. I'll go back into the profile and take a look at the programming, which addresses the losses that we talked about. So let's jump right to transformer line losses. So this is where we actually make the adjustment. There's a sheet that you have to work through, and eventually the values are entered here as a result of this calculated sheet. I'll open the sheet up so you can take a look at it. Oops, sorry. First I would have to enable. So you have a few options: copper only, iron only, and both Fe and copper, iron and copper losses. So I'll open up the Fe and copper losses drop down. And from there you have a few choices to make. You can add to watts and subtraction VARs, subtraction from watts and add to VARs, add to watts and VARs, and subtraction watts and VARs. From previous experience, I've usually set this to subtract from watts and VARs. So let's just take a quick look at that. We open up the calculator, and this is what you see when you open up the sheet. There's several tabs, instructions, how to go through the process, system losses, your transformer losses, line losses, and so on. Line losses is the first one we looked at as far as one of our compensation values. These are typically values that you will need to do some calculations to determine what the line losses are, and this is based on the length of the cable and other factors such as impedance, and that goes into this sheet and submitted finally and processed, and you would generate a report for transmission line losses. The other losses we talked about, transformer losses. These are where this is where you would enter your report, the transformer report information. So you would have to have this on hand. You would enter the information from this report onto this page, onto these pages here, and you would update the information. But you have to have the transformer report in order to do this. There are cases where you don't have a transformer report available, and so in those particular cases, you will have to do some work. You'd have to know what the voltage and current, if you're profiling voltage and current and other properties in the meter, and deduce from there what the losses should be. But that's that's a rare case where you don't have an actual transformer report. I'll close this out, and I'll jump back to the presentation real quick, and we'll go into, we talked about line losses, right? So this is what we just went through. Now we talked about the transformer losses, I apologize, and Ctbt compensation, which is the errors that are accounted for inherent in the meter, typically, inherent in the transformers, the instrument transformers. And so we'll again jump back to the communicator in the profile, and we'll take a look at the Ctbt compensation. So we'll scroll down, and here we are. And in this page, you have to select enable Ctbt compensation, and from there you can make your you would need the report from the transformer, and typically, I guess we said we test the meters, I should say, test the transformer, and we have a transformer report, and if that's provided by the manufacturer, and it would give you this information. But this is where you would make your adjustments, the value that you would enter in based on that report from the transformer manufacturer. So here we scroll through. These are all A, B, C, CTs, and then we'll go down to the PTs, and you have to use that same or similar approach as you did for the CTs, and you would enter these values into the meter. The next step along the way is power quality, and I'll just jump back again just for a moment. So power quality, as we talk about, is one of those ambiguous terms. It means something different to everyone for the most part, and it depends on what field you're in, how power quality affects you, and it's a very complex process in determining where your problems are or what type of power quality issue that you have. And so standards are always being revised, and that is something that to this day there's always an exception to the standard, and so things are always changing. So it depends on how you look at or what you're looking for, and what you're required to capture in power quality. That usually determines how you'll set your meter up for power quality capture. There's a book which I strongly recommend. It's called Power Quality Primer by Barry Kennedy. It's an excellent choice for getting an idea what you're trying to capture in power quality, and just all the different issues that you can have. And it also provides very good solutions to the problems. Okay, so we'll go back to the communicator, and we'll jump right into the power quality. So as I said, it's very complex power quality settings, and it's based on the type of load that you have, what your requirements are, what you're looking for. We have a worksheet here. Pretty much you can set your limits as far as what percentage you want above, below your normal, I should say, your normal voltage ranges or your current ranges. And here you have the option of selecting all the different voltages, A, B, C, and in this particular case, and it's very friendly arrangement where you can choose whichever you want, what voltage, your current, min, max demand, average demand, harmonics, and you could look at all your different values that you want to look at, your current voltage, your watts, VARs, power factor, frequency, your neutral current, and so on. So you have a multitude of choices to choose from. So you have to decide what your set point should be, and at that point you can then do an update to the meter. The next option we have here, or choice we have, is a waveform capture, which is a very good feature in the meter. It allows you to look at waveforms, and the meter gives you a lot of choices in capture rate. This particular meter sample rates up to 512 samples per cycle. you have pre-triggers that you could set at various levels, and you have your full range voltage scale and current scale, which is, this is a PT primary and secondary values. If you're going to set this up, you would need to check off these boxes for enable and waveform, PQ enable, waveform enable, and it will capture any value exceeding the percentage ratings that you've, the set points that you've provided. So we'll toggle back. So we discussed the power quality and waveform capture. So we'll get into that a little bit more as we go through. The next step in this process is the trending of the data that you're capturing. So trending allows for you to capture interval data from many points. The Shock 250 allows you to use to set up to 3 or 6 separate logs. Historical log profiles that can log up to 64 parameters. Each of these logs can log at different time frames. For example, one can be set for 1 minute intervals and record voltages, as well as frequency, phase angle, many different points. And you could set it at, again, it's as minimum as 1 minute to 60-minute intervals. So let's take a look at that. So we have the profile open, and we're looking at historical log 1. This meter, again, we have 6 historical logs. Before we go there, we could take a look at the configuration of log sizes. This has a nice feature that you can set the size of each log with a slider, and that determines how many days of data that you can record for that historical log. You can also determine, as we said before, down to 1 minute intervals you can log, up to 60-minute intervals. So here we have 6. We can adjust our slider to adjust how many days. It's 16 months. That's a long period. 31 months, 37 months of historical data. And that all depends on what your logs are basically programmed for. So I'll take a quick look at historical log 1. This meter is programmed to record volts, VAM, volts, VN, VBN, and VCN, IA, IC, IB, and IC, watts total, 3-phase power, VARs total, 3-phase power, frequency, voltage, unbalance. In log 2, we're looking for scaled energy, which is a total energy for that interval for 4 channels that are programmed. So you have watt hours delivered, watt hours received, var hours delivered, var hours received. We go to historical log 3, and here we're looking at total harmonic distortion, and we're looking at voltage on the first 3 channels and current on the first 3, on the second, I should say, 3rd, 4th through 6th channels. Then log 4, we're looking at unbalanced voltages, 0 sequence component, and we're looking at just symmetrical components, basically, that we're profiling on log 4. So you can have the meter program all these different channels or information that you're recording on all the logs simultaneously, and you could pull this information at any time. So log 6, we got nothing there. Log 5, nothing programmed, and so on. So basically that completes the logging information that you would want to set up. And let me just go over quickly, for instance, these values. So you have different groups that you can choose from, measured or really instantaneous values that you want to bring back from the meter. Energy is, these are, when we talked about scaled energy. Energy is the total energy recorded, watt hours, var hours, VA hours that are recorded for a period of time. So you have, the other thing is this meter has a scaled energy, which is basically our start readings. A meter actually brings in meter readings or register readings and brings them into the recorder, into the file, and for those intervals. And you could net the two of those start and stop readings, and that will give you the energy. And that's basically what the meter is doing. The next choice is energy interval, which is the total energy, as I mentioned before, which we found in one interval. That was programmed for log 2, as you can see. Then you have scale interval in pulses, which is basically pulse information that the meter records internally. Then down the stretch, we'll have uncompensated energy. If the meter is programmed for compensation, you'll have uncompensated energy and interval, uncompensated energy and interval pulses, sort of mirroring what you have in scaled and on scale energy values, except it would be uncompensated. The scaled energy, if the meter is programmed for compensation, would be the compensated value, and that you will see reflected in the registers themselves. Then you have secondary values that you could, if you need that option to have the secondary only option, you could record this information similarly. And that's just the grouping for the subgroup, I should say, for all the quantities that you could bring in, depending on what you want. And so we've done measured energy, then you have min and max values. We go through this. It's basically a lot of different instantaneous values that recorded in the meter that would be brought in for the min, the max, and min, and voltage, and so on. So there's a ton of information you could bring back from the meter, just choosing any of these options. And you have the flexibility to set up your logs where you can bring in specifically what you're looking for without affecting, let's say, your billing. So if you only wanted your scaled energy for billing interval data, that might work for you. If you're interested in looking at harmonic distortion, that might be, depending if you're in the RD group, you might want to look at the harmonic distortion and so on, or the power quality folks might want to see what the meter's recording. So, but yes, it gives you so many choices to pull from in the trending profile. And so as I go down here, we talked about the different interval sizes. So you have 1 minute, that's the finest resolution you can do for logging. And this extends all the way to 60 minute. And so that basically completes the historical logging trending feature in the meter. So I'll just tab back. So we are going to actually do a retrieval log. So let's take a look at that. So let's do a retrieval log. We talked about setting up all the logs. So one thing I like to do is just look at the log status screen real quick. So let me close out the programming. So let's say you did all of this, you would basically hit the update device. Before you did that though, let's say you thought maybe I need to check that information. This meter has a great feature in the software that you can look at all your changes prior to and pre and post changes before you actually write the information to the meter. So this can be very valuable. So this is something, anything that you would have changed would be highlighted, and you could at least go over that. Right now, nothing was updated, no changes were made. So this is a great tool to have to, review the data before you actually click update, and that would write that information into the meter. So at this point, you could also run a report, which is, basically all the information that you want. And also when you do, make your changes, your programming changes, you want to save the program, and this way you could import to the same meter if there's an issue, or another meter if you have a replacement, or just keep record of all your programs. Okay, So we were talking about retrieving logs. So one of the things I like to look at is this is the status screen that basically gives you an indication of what type of information you have in your trending, and this basically is this historical log 100% all the way down to the first four means the meter has filled up its buffer. Basically, it's a first in, first out at this point. And but you have data going back to January 3rd, 2020 for to 421, which is this morning at 11:15, and so on. So if you were to look at each one of the logs, you can get an idea how much data you have, how far back you can go back. So this just gives you, I like to use this, it gives me a general idea of what is in the meter, how far back I can retrieve data. So let's retrieve the logs. So this comes up the same screen, and actually from the status you could do the same thing, but I'd like to just go through the correct way of just retrieving the information. So let's retrieve logs, historical log. Let's do log 2 and log 1. Let's, as a matter of fact, let's do the 4 logs, and we could go ahead. It shouldn't take very long because I read it probably an hour ago. So it's basically just good to see all the different values that we're bringing in. So. Okay, and what we see on the screen is called a log viewer. As you can see in the background is a conversion process that's taking place, and it's basically bringing in all the information, processing it internally, and eventually when it's completed, it should allow us to open up the data files. So let's take a quick look at that. So here we are. This is the log viewer again. This is the ID that populates into this window here. This is a time select start and stop time. Is your time range. You can specify what period you want to go back, how far back. If you don't want to, this says it's currently selected for the last year, previous year up to present. If you just want the previous 2 hours, you could enter that value of 5 hours or whatever, or you can again, choose from any range that you want. The data points, these are basically all of the points that are programmed. When we did a retrieval log 1 through 4, those quantities were recorded in those channels. So it's made available into that area. And what I have in the right side of that screen is where we say scale energy and interval. That was log 2. And this is how I actually, since I looked at this previously, I set this value as a default. But basically I can have all these values come in, and these are what I want to view. It's like a menu choice that you could just select if I only wanted to look at, specific certain THD. If, again, I would have to pull logs 1 through 4 at least to bring in all these values. But I can view all this information. So I'll just select that, and well, in order to bring this information in, I could look at the historical logs. So the historical logs, it's updated. I could expand this. So the current time is 11:30. The last interval was 11:30. So those are 15-minute intervals. So you could see this. You can sort this in different ways, ascending or descending. If you want to, this will take us back as far back to the beginning of the file. So this actually has data going back to September 19, and that would be some of the points in THD. Apparently there's data there. So let's go back here. Sorry, let's go back again. Okay, so let's go with the descending version. So here we have the most recent reading, 1130. This is what our voltage was. That's 14 kV, basically, and this is your energy in an interval. That's the total energy in a 15-minute block. So this is basically 4 times that value for the total hour. So we could see approximately 4 megawatts is what we should be seeing for the hour. The VARs total, the VARs should say delivered, received, and again, THD is what we had selected. So if we want to take a closer look at this, we could go back and look at the waveform. I think one of the things we talked about, waveform capture. Let's select waveform capture. Let's go back again since we have a little time. Okay, so we have our data. So we can bring all this data into a spreadsheet by selecting the data area, the area that you want to bring in. We could copy this with a header or without a header, and we can paste this in an Excel sheet. So let's do new. And we could paste that information in a spreadsheet. And you could apply all types of math to this information, or you could just generate this report to someone who needs this information. So this is all the same information that we just brought in for the period that we were looking at. So let's take a look at the time just to make sure we get that right. Okay, so this is here actually the last download 1130, and this is the actual information that we saw in the interval logs. So this is a good way. You can save this in again Excel, and you could send this information to anyone who requests it. So we can close that. Where we can exit out of the log information. And let's just take a quick look here at where we are here. We completed that. Retrieval logs. We completed the log viewer. Again, we talked about the screens and waveform capture. So let's take a look at that, going back to the so we have the log viewer. The logs. We have a log that we saved. Oops. So I made a mistake along the way. I should not have closed the log viewer. So let's get an update anyway. So basically I'm retrieving the logs again. I did not have to do this step, but I could have, the file's actually stored on a local drive on my machine that I could actually open it in the log viewer, but I just went ahead and decided to do another download. It should be very quick, again, because we just downloaded the file previously. So let's take a look at the waveform capture. As we can see, based on the parameters that we set for waveform capture, we have an event that took place on April 19th at 12 o'clock. And so it actually gives you some information on this meter. And so let's take a look at what waveform capture looks like. So if I just double clicked on it, it opened up the waveform. And so it could show me what the sags and swells are. I see some of the data I'm looking at. I see here where it looks like it's a little bit noisy, but this is a representation of what the waveform looks like when you zoom into for that particular event. You can save the waveform, export this information to several formats. But let's close this and let's take a look at another one. See what we can open up. So we're looking for an event. It said trigger 419, 1158. And I'm basically looking at the saved waveforms. So here's a sag, and we could see how dramatic that looks where this is an event that took place. I double clicked on it and it actually opened up the waveform. So this is a very useful tool to have. And I would strongly recommend practicing and looking at setting your parameters for waveform capture, and just let it run over a period of time and view your waveforms. So we just completed that part, the trending, and we viewed some screens. Next, we want to take a look at the power quality, alarm settings, phasors, and so on. So let's close that from real-time tools, power quality and alarms. We first can look at the phasor, the first thing that comes up. So this is a perfect phasor diagram right now I'm looking at, and this is ideal. You may see this on a generator, but in most loads you'll see current offset because you will have inductive and capacitive loading. So, but this looks like it's purely resistive at this point, but it's a good representation of your wiring. This is an ABC rotation or positive sequence. So you have A, then comes B, and then comes C, and this is a 3-element Y type configuration. Here's your voltage and current and the angle. So there's really very little angle between. So if you were to add these up, multiply VI times the cosine, here is really 0. VI and A, watts A, B, and C, and you would get total power for that. But again, this is just a nice waveform to verify also wiring. So sometimes you have ACB rotation, you may have the currents reversed, or a lot of cases we find that they're wired backwards on the current when they apply the CTs, and so they have to, what we would use this as a tool to identify that for the most part, and then we can make recommendations of what you can do. So that's the phasor. The next step is the harmonics. So this meter captures up to 40, the 40th harmonic, and so as you can see, there are no harmonics in this. This is almost unreal situation. This is a meter in our lab. So the fundamental 60 hertz, there's nothing there. The first, I should say, is 60 hertz, and then from there you have a little noise on the second harmonic, but for the most part this is very clean. But this is a good representation of harmonic distortion that you could easily look at the meter when you first connect. Let's go to the next choice, symmetrical components. Typically, if you're familiar with symmetrical components, you'll see a significant imbalance due to line to ground faults and things like that, or in a normal arrangement where the load is severely imbalanced, you would see current on your neutral and neutral line, and that can create a lot of problems in your equipment, and can be dangerous if there's a ground fault. But a lot of times you can use this diagram and get an idea. So AB positive rotation, ABC is A is red, B is blue, and C is green. A negative, this is an ACB rotation. Um, and so on, and zero sequence indication. So, but this is our general phasor diagram, and this is pretty much positive sequence in line. So this gives you all the information, the magnitude and angle for each one, and very little unbalance based on the load. So if we were to do a quick load, we could see that there's some neutral current, and this is the small imbalance that you have in the current. So, but that's also very useful. So we have power quality, symmetrical components, harmonics. I think we're good there at that point. So what I'd like to do is one final step and take a look at the web browser and take a quick look while we have time to look at the setting up the alarms and taking a look at the limits using the browser. So let's close that. Let's see, I could disconnect at this point. Oops, disconnect. And let's take the address. Just post that in your web browser. And as you can see, it's a almost instantaneous connection. We're connecting over the network, so it's very responsive. So this, again, basically gives you all the information that you would see if you were connected to the meter using the Communicator EXT software. So you could be anywhere on the network. As long as you have access to the meter, you can view the meter voltage, current, power, status information, and you know, just get a general idea of what your load looks like. Let's go down to power quality. We talked about looking at the harmonics. There's nothing that we could see. This is not a very good example to demonstrate harmonics, but you can get an idea of what your harmonics look like, the third, the fifth, the ninth, and so on, all the odd harmonics. If we go down to the information tab, you get basically, I think we may have talked about this briefly yesterday, just the information on the meter itself, all the vSwitch upgrade version, I should say, whether passwords enabled, pretty much the information that you need to have. And let's just take a quick look at email notification. So this is where you would set up your email server information. So as let's SMTP dot, let's set typical port, TCP port 25 is your mail, at least it's a standard mail port. And so we can go out and click next. So here's where you set up your parameters, what you want to log, and notified once you get an email. So you could do all these different things: waveform capture, relay, digital input change, pulse accumulations, and so on. Let's say if we choose program settings or clock settings. Okay, so here you would set up your from and your to, and then again, these are what the points that you would like the email shall include. It's a general template type email response that you'll get, and it gives you some options, XML or CSV, and yeah, so basically this would be the step that you would need to go through. You need to know that from your IT folks what your email server is that you would put this in. Some companies won't allow you to use the email server, so you have to use a third party, but it's something that it can be very useful. You can, when you set the meter up to alarm and notify on limits, certain limits that you may have exceeded, can be very important data that you're looking for. So you need to get that right away. So it's something that can be very useful. Okay, one other thing I'd like to add before I close is just like to do a quick setup with the meter, just to go over real quick, the meter time. Oh, I'm sorry, password. I didn't talk about that, but we'll do it real quick. Security. So if we want to enable security on the meter. It's an encrypted password. You would enter that information here, and basically you can set the meter up to have certain levels, up to, I think, I'm thinking it's 8 levels of password that you can use. I don't remember, but it's many different levels, and you can set the rights to the users to be able to access certain functions in the meter, and it's very good. You can have technicians that you don't want to have admin rights, and that, let's say you just want them to set registers or read registers, you can just select the different levels, but that's there in the software. I'm running close to the end of my time, so I couldn't go too much in depth with it, but it's very useful. And having said that, I think I'm at the end of my rope here, or if anyone has questions, please send those in. And we'll try and answer them.